So as we talked about in class, this is a slightly silly problem because you have a 4-meter long rope with a 2-kilogram weight attached to the end of it. It's kind of hard, and it's undergoing a horizontal circle. So what we're actually looking at is the top view, or the bird's eye view, top view of this circle. And in this case, force of gravity, the normal force, like we drew in the last question, we can say that if you were looking at it from the side, you would have the force of gravity acting down and you'd have the normal force acting up, and we're saying that those two forces are balanced. The only force that's acting, in this case I can actually draw it, it would be like the tension force pointing to the center of the circle, and that's what's causing the centripetal acceleration. So essentially this stone, it wants to do what stones do, and that's travel at a constant velocity in a straight line. It's prevented from doing that by the centripetal force, in this case supplied by the tension in the rope. That's a force pulling it towards the center of the circle. So it's asking us, what is that tension force? And in this question, we have things like 5 revolutions and 2 seconds. So the idea here is that we would need to not use, we have our 3 equations. In this case, FC equals mv squared over r might not be the most convenient one to use. We have 2 others, FC equals 4 pi squared mr f squared, or FC equals 4 pi squared mr over t squared, where f and t are the periods. It doesn't matter which one you use. The last 2 are more suitable. So how do we find the frequency or the period? We would use the revolutions and the time. So frequency has a formula that is the number of revolutions divided by the time taken. And as you know, the period is the inverse, so it's just time taken divided by the number of revolutions, or the number of cycles, both of them, the same thing. So, I don't know, let's just do the frequency one. So what we would do is, to find the frequency, in this case, we would say the number of revolutions is 5, and the time it takes is, so 5 revolutions, and the time it takes is 2 seconds. So in this case, my answer would be 2.5. And the units here, as you can see, revolutions per second, which is another way of saying hertz. Hertz is a revolution per second. Okay, so now that we know the frequency, we can find the centripetal force. So it's back to this whole thing again. FC equals the sum of the forces, which equals 4 pi mr 4 pi squared mr f squared, and then we can say this is supplied by the tension. So the sum of the forces is Ft, which equals, and we can plug in the numbers, 4 pi squared. The mass in this case is 2 kilograms. The radius is 4 meters, and the frequency we just calculated was 2.5 squared. And so we can determine our Ft, which is 1,970 newtons. And that's the tension that the rope has to withstand in order for the ball to go around in this rather large circle.